Hello, everyone. What I want to do now is go over 414 and 415 from the uncollected homework. These are both similar to collected homework problems, so I think it's worthwhile to go over this. Additionally, normally when I teach this, for example, in the last time, spring 2023, I do go over these problems in class. So yeah, let's get to it. Let's do 414 first. So I have a 6% bond maturing in 8 years with semi-annual coupons that yield 5% convertible semi-annually. And this is replaced by a 5.5% bond yielding the same rate. In how many years should the new bond mature if they both have the same price, yield rate, and face amount? Okay. So first of all, it's not specified if the 6% is nominal semi-annual or not. So we're going to assume it's nominal semi-annual. Same thing with the 5.5%. We just assume it's nominal semi-annual. Okay. Especially when we have semi-annual coupons, I've never seen a problem that has semi-annual coupons but a yearly interest rate. So we're going to always assume, unless otherwise stated, all rates are nominal semi-annual. All right, so and you're not given a face amount, but they both have the same face amount, face value, same thing. So I think it's easy just to set it to be 100. In the uncollected homework solution, I just left it to be F and just canceled it at the end or close to the end. Up to you. Okay. So let's do bond one first, write down all my information. F is 100. My yield rate that I'm given is 0.05. That is, yeah, for bond one, it's a 5% yield rate. Right? We're given, this is, what is it? 6%. So 0.06 over 2. All right. So K is F times 1 over times your present value factor corresponding to the actual 6-month yield rate of 2.5% raised to the number of 6-month periods. Is an 8-year bond, so 16 6-month periods. So just plop this into Maycham's formula. It's K. Move this down a bit. About that. So it's K plus R over J times F minus K. And this is going to be 106,528. Okay. So that's sorry, forgot the 1 here. That is bond number 1. Okay, so let's go to bond Okay, so the face value is 100. The price is the same, yield rate and face value are the same. I just wrote that, sorry about that. So let me write down the yield rate. Remember that is 0.025, the actual 6-month yield rate. We're given that my semi-annual nominal coupon rate, bond rate, same thing, is 5.5%. So my actual 6-month bond rate is 2.75%. Okay. And we don't know what n is. Okay, that's fine. Okay, so yeah, just do same thing, make Ham's formula. Okay. So here k is 100, 1 over 1.025 to the n. We don't know what n is. That's fine. So it's k, just use make Ham's formula. Plus r. Sorry. That's a little weird. Sorry about that. R is R2 over 2, and that's 0.055 over 2. Sorry about that. Okay, so it's R over J, 0.0275 over 0.025 F minus K. All right, and let's make life easier by setting this to be X. So 100x. Do this in a calculator. 0.0275 over 0.025. I think it's a nice number. Yes, it is. Plus 1.1. 100 minus 100x. Okay. So factor out the 100, 100x plus 110 minus 110x, and this becomes 110 minus 10x. All right, but these are the same, these two prices. Second. Okay, so 106528. Problem member states that the two prices are the same. All right, so we get x is 0.3472. And remember, this is 1 over 1.025 to the n. All right, so solve for n, we get, what is n? Now, n has to be an integer, because this represents a number, an even number, not even, just an integer number of 6-month periods. So we round up. I'll just round to the nearest integer, 43 6-month periods, or to 21 and a half years. I'm happy with either answer you give me. But either one, that's the answer. Okay. All right. So let's do 415. So maybe not a little more complicated, but really not too bad either. Don purchases a 1,000 par value 10-year bond with 8% semi-annual coupons for $900. He's able to reinvest his coupon payments at a nominal rate of 6% convertible semi-annually, so that means it's nominal semi-annual. Calculate his nominal annual yield rate, convert semi-annually, semi-annual nominal yield rate over the 10-year period. Okay, so we'll get more into kind of what generically yield rates mean when we do internal rate of return. But whenever you have a one-time purchase or one-time investment, rather, this is just the in this case the equivalent effective annual interest rate, but converted to a nominal semi-annual interest rate. Okay, so yeah, I'll do that. I'll get the equivalent effective annual interest rate and then convert it to a nominal semi-annual interest rate. So the idea here is very simple. You invest $900, and then at the end of 10 years, you get your 1,000 back. So I should specify par value means face value. They're synonymous. They're the same thing. So you get your 1,000 back after 10 years, and you get the accumulated value of your coupons after 10 years. So you spend $900, get those two back after 10 years. The face value of 1,000, par value, same thing, and the accumulated value of your coupons. Okay. So, and one thing to make clear, and you should notice that you're not given a yield rate for the bond. That's fine. You don't need it. Yield rates are important only to calculate the price of a bond. And we already know what the price is. He buys it for $900. So we don't have the yield rate and we don't need the yield rate. All right, so let's get coupons. So I'm given that R2 is 8%. Sorry. So R is R2 over 2. And this is 0.08 over 2, 0.04. So remember, the problem states the face value is 1,000. And the the actual 6-month coupon rate is 4%. Okay. So this is going to be sorry about that. Okay, sorry about that. So yeah, your coupons are going to be $40. Okay, so you don't really need a time diagram, but no harm in writing it. So this is 6-month periods. So it's 10 years, so 19, 20. But it might conceptually help. So, so 40, 40. These are your coupons, and you get your 1,000 back at the end. Sorry. So the accumulated value of coupons plus your face value is 40 S20. Remember that this is a 6% nominal semi-annual rate for your account that you're reinvesting, or that Don is reinvesting the coupons in. So we divide by 2 to get 0.03 plus 1,000. So we're actually almost done. Plop this into the calculator. You'll get where is this? second. 2074. 2074 and 81498. Okay, now you can do one of two things. So let's get the equivalent effective annual interest rate, and then I will convert that to a nominal, equivalent nominal semi-annual rate. So we invest 900 into this hypothetical account, earning a yearly interest rate of I for 10 years. And we get back what we actually get back after 10 years. What is this I? So let's see. 207481,498 over 900. So it's 8.711. Which is pretty damn good. I would be very happy if I knew an investment that give me that. So yeah, 0.0871. Okay, so last but not least, convert this into a nominal semi-annual interest rate. It's 2. Raise this to the 1/2 minus 1. So square root this. Minus 1. 0.08529. All right, or let's get my actual 6-month equivalent rate for this 26-month period, for this 10-year period. So we're plopping 900 into an account earning this interest rate J per 6 months, compounded for 26-month periods. This equals the actual amount we have after 26-month periods. So I don't have that anymore, but that's fine. Yeah, let's check. We get the same answer. Better get the same answer. Okay, so raise this to the 1/20 is 0.05. Okay, so this is my 6-month interest rate. The equivalent 6-month interest rate for this 10-year period, 0.042646. And what I called I2 here, I guess I called J2, whatever. Just multiply by 2 to get the same answer, 0.08529. That's okay, yeah. So like I said, you just remember multiply your actual 6-month rate by 2 to get the nominal semi-annual rate. Okay. So yeah, that is your answer. They ask for anything else? No, that's it. So all right, so yeah, hopefully this helped. And yeah, course is almost over. Just a little less than 2 weeks. Hard to imagine. All right, so long. Take care. Bye bye.